I worked at ARM and focused on the enterprise software ecosystem. Today, I would like to share some information about the Moby and LinuxKit project on ARM64 server. Maybe some of you know, you already know the two projects announced by Dog Company on April this year. Docker is a big project with many component libraries and tools. But in this technical session, for the time reason, we can only cover one of its components, the Moby tool. So actually, the title of this slide should be Moby tool and LinuxKit on ARM platform. So let's get started. This is today's agenda. The first two is general for the two projects. And the rest is ARM-specific part. In the first part, we will talk about the overview of the two projects. And it will give us a big picture of what the technical session will talk about. And second, we will have a discussion about design principle of the LinuxKit project. And then we will end into the second part. Firstly, we will talk about some challenges and issues we encountered on ARM platform when we support the LinuxKit on ARM platform. Next, I will give a status update of the LinuxKit support on ARM platform. Then, I want to share some information about the patch we do contribute to the LinuxKit community. After that, I want to discuss. I want to have talk about the next plan we want to do in the future, some issue we need to address, and some improvement we want to do for the LinuxKit projects. Finally, we have a LinuxKit demo on the ARM platform, but this demo is not on today. We will make the demo on Friday, the Connect demo day. So this is an overview of the two projects. It will give us a big picture of where we are. It will tell us where the LinuxKit and the Moby tools. And also, we can see that logically, these two diagrams have two parts. The left is for the upstream projects. The right is the downstream products. And generally, with the use of the use of the upstream project to generate the downstream products. For example, you can build the Docker product from the Moby tool, from the Moby projects. Of course, you can create your own product according to the requirement of your specific use case or use scenario. So from this diagram, we can see where the LinuxKit and where the Moby tool. And we also know that how they interconnect with each other. For example, we build the LinuxKit distribution from a YAML file, and to generate the final products. In this example, it's a Linux distribution named Dolphin LinuxKit distribution. This is a typical workflow, and the workflow demonstrates that what's the relationship of the two projects and how they work together to create a brand new products. So, so now we can get a summary of the LinuxKit, what the LinuxKit is. Just as the text in the right side tells, LinuxKit is a toolkit to build a secure, portable, and lean Linux distribution on demand. And all system services in the LinuxKit distribution will exist in form of a container, which can be replaced and removed according to your specific requirement. In this slide, we will talk about the design principle of the LinuxKit project. It's a core belief of the projects and some kind of something like the code of conduct when you want to contribute some code to the LinuxKit community. There are two diagrams in this slide. The left is for the traditional Linux distribution. We also call it general purpose Linux distribution. And on the right side is containerized distribution by LinuxKit. Sometimes we call it LinuxKit distribution or LinuxKit system. Each of the diagram we can see there are three layers from the bottom to the top. They are the hardware layer and the hypervisor layer and the QEMU virtual machine instance layer. And from this diagram, we can see the only difference between them is on the top layer. The top layer is, just as I mentioned, the top layer is runtime QEMU virtual machine instance layer. In that layer, we can see that for the LinuxKit, each system, the LinuxKit system is constructed based on the container. So in that layer, each where icon stands for a standalone container. So that means everything in the LinuxKit can be replaced or removed. So this is a difference between the two distribution. So now we can see that the typical feature of the LinuxKit is it's customizable, because just as I mentioned, you can all the system service is container, and the LinuxKit system is constructed based on the container, so we can easily add or remove some system service from the final distribution. And the lightweight, because the base image, the size of the base image is very small. Typically, it's tons of megabytes. So also totally image size of the finally LinuxKit distribution is very, very small. And no redundant service, because we can customize the system, so we can remove or replace or add some system service into the final distribution according to your requirement of your specific usage scenario. So as a result, there will be no redundant services in the system, in the final system. Resource isolation directly benefit from the built-in feature of the container, because we know that the container has a resource isolation based on the C group or namespace. So it will be easy to do the resource isolation for the system for the different system service in the LinuxKit distribution. Security is a top-level objective of the LinuxKit project. Because just as mentioned, it's very simple, and it's a lightweight distribution. So the attack surface of the LinuxKit typically much smaller than they would be with the traditional Linux distribution. So there are very few opportunities to attack or compose Linux kit distribution. The last two features, faster boot and quick deployment, because the Linux kit distribution image is very small, very tiny, and so we can boot the system very quickly, comparing with the traditional Linux distribution. So this is a design principle and some kind of the code of conduct. So if you want to contribute some code to the LinuxKit community, we need to think about those code of conducts before we do that. Okay, now we enter into the second part. The second part is totally the ARM platform specific. First, I want to share some challenges and issues on ARM platform when we support LinuxKit on ARM64. First is, at the beginning of the LinuxKit project, it's hard code to AMD64. So that means if we want to support ARM architecture, we need to refactor the code and to remove this kind of hard code. And the second is, we need to support both architecture with only one code base, because it's very easy if we have a different code base for each architecture. But the goal for us is to support the multi-arch with only one code base. And the third is about the multi-arch Docker image support. We need to consolidate the arcs into one Docker file. This is especially in the Docker file. We need to add the runtime code to recognize the architecture, and the system is running. And also, on ARM64, there are some specific packages are missing from the Alpine distribution. The Alpine distribution is the base image of the LinuxKit projects. For example, the Open Virtual Machine firmware package is not exist on the Alpine distribution for ARM platform. So that will raise challenges for us to support the LinuxKit on ARM platform. And also, there is some packages. Some packages cannot work on ARM64. For example, Gumi boot tool. It's a big topic to generate the ISO LinuxKit image. We will give more details about this topic later on in the following slides. So this is challenges and issues we encounter on ARM platform. Some of them have been addressed, and some of them are still on there, and we need to be addressed in the future. This is a status update slide. I want to give a status update of the LinuxKit support on ARM platform. It's about the history and the background of this project. I mean, the LinuxKit support on ARM platform. It's about this slide is draft according to the sequence time node. On Apple this year, because Doc has planned to support LinuxKit on ARM64. So with that, ARM began to involve in this kind of support. On July this year, we at the beginning for this kind of support, we just forked a separate code base from the main line of the LinuxKit Git repository, and for that forked LinuxKit code base, we just focus on the ARM architecture. We don't care about the x86. So it will be easy to support LinuxKit and easy to run LinuxKit on this forked LinuxKit code base. And we finished on the July 6th, and we post this in the LinuxKit community. So after that, at that time, the forked Linux code base can run the LinuxKit on ARM platform. After that, we need to merge the code in the forked code base into the mainline, upstream mainline code base of LinuxKit. So we work closely with the LinuxKit community to merge the code. And finally, we make the LinuxKit the mainline code base of the LinuxKit can run on both the ARM64 and the x86. So the August 4th data comes from a Twitter post by Rolf. Rolf is one of the maintainers of the LinuxKit. So this is why the data here. So this is a status update of the LinuxKit support on ARM platform. Okay, so in this slide, I want to share some information of the what we have done for this kind of support. And we will talk about the patch we made and contribute merged by the upstream in the LinuxKit community. And we currently from now we have 13 patches merged by the upstream. Some of the merged patches will refactor the original ARMD64 only hardcode. We need to remove the hardcode from the LinuxKit project because, just as mentioned, because at the beginning, the LinuxKit is hardcode for the ARMD64 architecture. So we need to refactor the code to support the ARM platform. And also, we need to refactor the doc file to support multi-arch, because at that time, all the doc file is for the x86. And we also boot up the ARM64 kernel for the LinuxKit. So after that, we can run the ARM kernels with the LinuxKit. And also, some of the patches is used to fix some bugs on the LinuxKit projects. For example, the QEMU fixed the networking issue in tap mode on ARM64. With this patch, we can make sure the LinuxKit running inside the QEMU instance. QEMU can communicate with the outside world. So that's very important for the demo on Friday, because we need to access the microservice, I mean the NGX running in the LinuxKit distribution. And we also specify the external firmware binary for the containerized QEMU, because we need to specify firmware to the LinuxKit to support the the UEFI and also the something like the ACPI. And the last last one is the one patch on the upstream review. I remember that I submitted this patch about 1 month ago, and we have a long review. And it's related about the ISO format image generation with the Grub2 bootloader. Maybe it's related with the security, so it takes long time in review by the LinuxKit community. But this information is a little bit out of date, because the first night when I arrived here, and I suffering the jet lag. I cannot sleep, and so I can't sleep. So I began to work on this patch and work with the maintainer. And at that time, I have no physical ARM platform, ARM machine. So I need to thank to the pack.net. I think Ed is here. And with the help of the pack.net, I have an ARM64 server ready to debug the code. And with that, after the work after a sleepless night, the PR has been merged finally. So it's for me, it's a good news. And I want to also thanks to Ivy and Justin, the maintainer of the LinuxKit, to make it happen. So the next step, I want to share some information about what we want to do in the future. The first is security. Just as I mentioned, security is a top-level objective for the LinuxKit projects. And for the ARM-specific, we still need to improve the content trust build, and also the secure Grub2, such as the TPM, and verify the kernel when the bootloader to load the kernel into the system. And also we have a plan to the performance optimization, because the optimization, the performance is for both footprint and speed. We need to make the LinuxKit as tiny as possible, And also, we want to make the boot speed of the LinuxKit is very, very fast, comparing with the traditional Linux distribution. And the third item is Alpine Linux distribution, because Alpine is a base image for the LinuxKit. So we, just as mentioned, that there are some packages still missing from the Alpine distribution, and some of them still cannot work on ARM platform. So we have some work to do in this area. The last is the networking issue. Currently, the LinuxKit is heavily dependent on the DHCP. So if we in some usage case, if a DHCP is not available, we need to configure the networking manually. And each time when we after we reboot the LinuxKit, we need to reconfigure the networking manually. So so we need to find a way to configure the Linux, to configure the networking for the LinuxKit in case of the DHCP is not available. So this is the plan of our next. Okay, so it's advertisement time for today's technical session. We will have a LinuxKit demo on ARM server. But it's not on today. It's on Friday, the Connect demo day, and we will want to make the demo on the Qualcomm Centrico 2400 platform, and also if we can do the demo from the ARM64 server hosted by the packet.net. And in this demo, we will show how to customize and build a LinuxKit distribution image. Just as I mentioned, for the LinuxKit, comparing with the general purpose of LinuxKit, you can customize the final distribution. You can add or remove or replace some system service from the to the final LinuxKit distribution. And in this demo, we also show how to make a resource isolation with a namespace. This is a built-in feature of the container. And we also want to show how to generate a tiny LinuxKit distribution with NGX as a microservice. NGX is we will include the NGX into the final Linux distribution. NGX will run inside the container, and for the NGX microservice will be sandboxed in the container, so it's bring the security benefit. And I hope see you on Friday, the demo day. And because for the time reason, we only have 25 minutes for the technical session. I decided to remove the Q&A session from the technical session, and so we will directly to the next slide. But it's most important. Thank you very much. 谢谢。